A single flaw in the autonomous navigation systems of a driverless urban pod could instantly spark catastrophic chaos across an entire metropolitan grid. Yet massive technology conglomerates are currently manufacturing thousands of these steering wheel-free machines to deploy directly outside your front door. The boundaries of traditional mechanics are collapsing rapidly, replaced by artificial intelligence algorithms and biometric sensors that read human pulse rates just to start an engine. Heavy cargo ships are reviving ancient wind power through towering metallic sails, while subterranean tunnels are being bored deep beneath congested highways to transport electric chassis at terrifying speeds. Join us and let's discover the bizarre machines rewriting the rules of human movement. Let's go.
Number 13. Gibbs Quadski. Plunging a high-speed, all-terrain quad straight off a jagged dirt cliff into deep water triggers a mechanical sequence that transforms the entire chassis in less than 5 seconds. Engineering teams spent years perfecting a highly aggressive suspension mechanism that forcefully pulls all 4 heavy wheels upward into specialized wheel wells, a movement mimicking a sea turtle rapidly retracting its flippers to escape a predator. A standard high-output marine engine instantly takes over, blasting pressurized water out of a rear directional nozzle with enough raw kinetic force to lift the heavy composite hull entirely onto a hydroplaning plane. Navigating turbulent rivers and flooded disaster zones becomes a seamless, violent rush because the exceptionally low center of gravity keeps the vehicle perfectly stable against deadly crosscurrents. Emergency rescue teams deploy these machines to eliminate the critical, life-threatening minutes normally lost switching between wheeled transport and rescue boats during severe flash floods. Drivers maintain open throttle control the entire time, hitting 45 miles per hour on fractured asphalt before violently smashing through the waterline without touching the brake pedal. Surviving a high-speed impact with hidden rocks requires an impact-resistant lower shell engineered to withstand extreme blunt force trauma. Yet the ambition to conquer vast oceans demanded engineering on a terrifyingly massive scale.
Number 12. Ocean Bird. Towering 260 feet above the dark ocean surface, 5 massive rigid sails dominate the deck of a heavily modified transatlantic cargo vessel. The shipping industry currently burns millions of tons of highly toxic bunker fuel, generating an environmental catastrophe that engineers are desperately trying to solve by resurrecting ancient navigation principles through modern aerospace technology. These colossal vertical wings are not made from traditional canvas, but from advanced composite steel and lightweight fiberglass, operating exactly like the aerodynamic wings of a commercial airliner standing completely upright. A complex array of algorithmic sensors constantly measures wind velocity, barometric pressure, and approaching storm fronts, automatically rotating the massive sails in real time to capture maximum thrust without requiring a human crew on the deck. Pushing 32,000 tons of heavy vehicular cargo across the treacherous North Atlantic requires immense continuous power, and this wind harvesting architecture slashes toxic emissions by a staggering 90%. When the ship approaches low suspension bridges or encounters violent hurricane-force winds, specialized hydraulic pistons telescope the massive wings down to a fraction of their height to prevent catastrophic structural collapse. Transporting cargo across the surface is undergoing a massive revolution, but solving gridlock on solid ground required digging deep into the subterranean darkness.
Only 1% of people know the dark truth behind what we are about to show you next. If you want to be part of the few who actually know what's happening in the world, subscribe and leave a like right now. Done? Look at this.
Number 11. The Boring Company Loop. Buried 40 feet beneath the sun-baked concrete of Las Vegas, a sterile, neon-lit network of claustrophobic tunnels moves thousands of human passengers at staggering speeds. Escaping the suffocating gridlock of traditional urban highways required abandoning the surface entirely and deploying massive rotary boring machines to carve narrow, precise tubes through solid bedrock.
Inside these subterranean arteries, a fleet of heavily modified electric vehicles operates completely isolated from unpredictable weather conditions, reckless pedestrian traffic, and complex surface intersections. The original vision proposed automated magnetic sleds carrying personal cars at 200 miles per hour, but the current operational reality relies on human drivers navigating the extremely tight single-lane passageways where a single steering error could violently scrape the concrete walls. Hundreds of thousands of daily commuters are funneled through underground stations illuminated by cold, vibrant LED strips, descending via escalators into a subterranean transit ecosystem that feels entirely disconnected from the natural world above. Expansion plans aim to hollow out a massive interconnected labyrinth beneath the entire metropolitan grid, theoretically erasing surface traffic jams forever by stacking transportation routes infinitely downward. Escaping the ground entirely presents a different survival challenge, pushing innovators to strap heavy battery packs to lightweight frames.
Number 10. Richter Skyrider X1. $60,000 purchases the ability to completely ignore congested asphalt and launch directly into the open sky from a standard suburban driveway. The Richter Skyrider X1 fuses the aggressive, exposed ergonomics of an electric racing motorcycle with the terrifying vertical lift capabilities of a heavy-duty industrial drone. Unfolding 4 carbon fiber arms from the central chassis reveals 8 coaxial propellers that generate enough downward thrust to rip the heavy machine off the ground without needing a single inch of runway. The physical frame relies heavily on advanced aeronautical aluminum, keeping the entire structure incredibly light while retaining enough tensile strength to survive violent atmospheric turbulence. Reaching a top speed of 60 miles per hour suspended hundreds of feet above jagged city skylines requires a triple redundant flight computer that processes gyroscopic data continuously, stabilizing the craft against sudden, deadly wind shears. Operating this machine strips away the protective cage of a traditional aircraft, exposing the pilot to the raw, rushing wind and the terrifying reality of high-altitude vulnerability. The ultimate failsafe relies on a ballistic emergency parachute packed tightly beneath the seat, designed to blast outward if all electrical systems suddenly go completely dark. Plunging into an environment even more hostile than the open sky required mimicking the precise, deadly hydrodynamics of an apex aquatic predator.
Number 9. Sea Breacher X. Trapped inside a watertight acrylic canopy, the pilot of a semi-submersible watercraft executes maneuvers that forcefully shatter the boundaries of traditional nautical engineering. Powered by a violently loud supercharged engine, this 2-seat vessel tears across the water surface at 50 miles per hour before the operator violently pushes the control sticks forward, plunging the entire craft directly beneath the dark waves. Traveling at 25 miles per hour underwater relies on a specialized dorsal snorkel tube that continuously sucks ambient air down into the internal combustion chamber, preventing the engine from instantly choking to death in the depths. The terrifying exterior shell is meticulously custom painted to resemble the scarred flesh of a great white shark or a killer whale, complete with aggressive pectoral fins that act as high-speed hydrodynamic diving planes. Pulling back hard on the controls redirects the massive vector thrust nozzle, launching the entire heavy machine out of the water at a steep 90-degree angle to mimic the explosive breaching attack of a wild ocean predator. The sensory isolation inside the cramped, humid cockpit forces the pilot to rely completely on complex dashboard instrumentation to navigate the murky, high-pressure environment outside the glass. Replacing heavy mechanical controls with biological sensory inputs became the obsessive focus for an entirely different group of luxury automotive designers.
Number 8. Mercedes Vision AVTR. Replacing the standard steering wheel with a pulsating biometric control pad completely eliminates the mechanical barrier between a human driver and a heavy rolling machine.
The exterior chassis of this concept vehicle mimics a living, breathing, biological organism, featuring 33 active bionic flaps across the rear surface that flex, raise, and lower like the defensive scales of an aggressive reptile reacting to a threat. To initiate the ignition sequence, the operator must press their bare hand on the illuminated central console, allowing advanced biometric sensors to read their exact pulse rate and respiratory rhythm before granting control of the drivetrain. 4 massive, illuminated spherical wheels replace traditional rubber tires, operating entirely independently to allow the heavy machine to strafe completely sideways or move diagonally like a crab scuttling across a toxic beach. Powering the silent motors requires a radically advanced graphene-based organic battery chemistry that completely eliminates the destructive mining of rare earth metals, allowing the energy core to be fully composted into the earth after its life cycle ends. This integration of cinematic science fiction and high-end automotive engineering creates a terrifyingly beautiful vision of a future where vehicles react to human emotion. Conquering the massive distances of the upper atmosphere demanded a structural behemoth that shatters all known aviation scale records.
Hauling experimental hypersonic vehicles to the extreme edges of the stratosphere requires an aircraft so incomprehensibly massive that it requires 2 separate commercial fuselages bolted together. The Stratolaunch Rock currently holds the absolute record for the longest wingspan of any flying machine in human history, stretching a terrifying 385 feet across the tarmac. 6 enormous jet engines, scavenged directly from heavy commercial airliners, roar with deafening intensity to drag this colossal composite structure down the runway, generating enough thrust to lift 500,000 pounds of dead weight into the freezing sky. The bizarre twin fuselage architecture creates a massive open void directly in the center of the aircraft, specifically designed to carry highly volatile experimental rockets and drop them from terrifying altitudes. Launching payloads from the thin upper atmosphere completely bypasses the dense lower air pressure that burns massive amounts of rocket fuel during traditional vertical surface launches from concrete pads. The flight crew occupies only the right fuselage, leaving the left side completely empty and sealed off, creating a deeply unsettling visual asymmetry that heavily distorts the human brain's understanding of aeronautical balance. Escaping the atmosphere requires immense industrial power, but democratizing the sky for individual consumers required stripping aviation down to its absolute bare minimum.
Number 6. Pivotal Helix. Bypassing the grueling, heavily regulated process of obtaining a traditional pilot's license allows absolutely anyone to purchase and operate a personal electric aircraft. The pivotal helix violently disrupts standard aviation design by eliminating complex mechanical hinges entirely. Instead, the entire structural wing assembly simply tilts backward so the craft points straight up at the sky like a ballistic missile. Pushing the throttle blasts power to 8 fixed-pitch propellers, ripping the single-seat carbon fiber shell off the grass before aggressively pitching forward to transition into fast, highly efficient winged flight at 60 miles per hour. The exposed, cramped cockpit surrounds the pilot with reinforced composite materials, relying on a triple redundant automated flight computer to instantly correct aerodynamic instability without waiting for slow human reflexes to react. Because it weighs remarkably little, federal aviation regulators classify the machine as an ultralight vehicle, granting complete legal immunity from the heavy bureaucratic restrictions that suffocate traditional commercial flight testing. Storing the entire aircraft requires only a standard 16-foot trailer, allowing owners to easily tow their personal flying machine to an empty field and assemble it in less than 30 minutes. Taking control away from the human entirely and trusting an invisible artificial intelligence to navigate the crowded sky sparked a massive, highly controversial technological race.
Number 5. EHang 216. Trapping 2 human passengers inside a sealed glass dome with absolutely no flight controls creates an intense psychological test of trust in artificial intelligence. The EHang 216 completely removes the pilot from the equation, operating as a fully autonomous aerial transport pod that relies on a centralized remote supercomputer grid to calculate exact flight paths over densely populated urban zones. 16 independent high-speed electric motors spin razor-sharp carbon fiber propellers, creating a deafening mechanical hum as the vehicle lifts heavily off the rooftop helipad and merges into an invisible digital traffic corridor. The structural core utilizes military-grade titanium and advanced composite polymers to maximize impact protection, while the redundant propulsion systems guarantee the heavy pod will not drop like a stone, even if multiple engines suffer catastrophic failure mid-flight. Commuters simply punch a designated landing zone into a sterile touchscreen, sit back, and watch the sprawling concrete grid of the city pass hundreds of feet below them, while an algorithm handles the brutal crosswinds. Dozens of cities globally are actively testing these pilotless machines, desperate to establish high-speed aerial transit networks that completely bypass the suffocating surface gridlock. Creating a machine that physically alters its own structural anatomy to transition between the asphalt and the sky remained the ultimate obsession for ground-based engineers.
Samson's Switchblade. Slicing through highway traffic in a low-slung, aerodynamic 3-wheeled sports car provides no hint of the violent structural transformation hidden beneath the metallic surface. Upon arriving at a designated airstrip, the driver triggers a complex hydraulic sequence that violently rips open the protective underbelly panels, forcefully swinging 2 massive aerodynamic wings outward into a rigid locked position. This mechanical metamorphosis takes less than 3 minutes, completely erasing the historical boundary between a street-legal performance vehicle and a high-altitude aircraft capable of reaching speeds exceeding 200 miles per hour. A massive liquid-cooled engine powers both the rear driving wheel and the heavy aerial propulsion propeller, demanding extreme thermal management to prevent the entire internal compartment from melting down during sustained altitude climbs. The glass dashboard instantly shifts its interface, replacing standard street speedometers with complex aviation telemetry, barometric pressure gauges, and real-time radar mapping to track approaching storm cells. Owners bypass grueling commercial airport security checkpoints entirely, driving their heavily engineered machines straight out of a suburban garage and directly onto the runway tarmac. Conquering heavily ruined post-apocalyptic terrain required a completely different approach, abandoning wheels entirely in favor of terrifying robotic limbs.
Crawling over a fractured landscape of shattered concrete and twisted metal requires a vehicle that completely discards the concept of a static suspension system. Operating standard tires in a ruined disaster zone is a death sentence, which is why the Hyundai Elevate utilizes 4 massive, fully articulated robotic limbs capable of extending outward and stepping independently over deadly vertical obstacles. When an earthquake obliterates standard highway infrastructure, the onboard algorithmic brain shifts the heavy machine into a terrifying reptilian walking gait, utilizing internal electric actuation motors that generate bone-crushing torque to lift the cabin over 5-foot walls. The passenger compartment remains perfectly horizontal while the external legs violently twist, lock, and heave the chassis forward across unstable mud, ensuring severe trauma victims inside do not suffer fatal secondary injuries during the brutal extraction. Once the machine reaches intact asphalt, the massive robotic joints fold tightly back under the armored underbelly, engaging the wheel hub motors to transition instantly back into a high-speed highway cruiser. Emergency rapid response teams rely on this terrifying structural versatility to penetrate the absolute center of destroyed metropolitan zones long before heavy bulldozers arrive. Achieving vertical flight while maintaining the exact visual footprint of a standard luxury sedan demanded an even more insane mechanical compromise.
Aleph Model A. Trapped in a suffocating gridlock, the driver of a silver mesh coupe violently engages the flight sequence, causing the entire vehicle to lift perfectly straight up from the congested asphalt. Escaping the surface without a runway required engineers to completely hollow out the traditional car body, replacing solid metal panels with an aerodynamically porous cage that hides 8 massive electric lift rotors spinning furiously inside the chassis. Once the vehicle clears the surrounding skyscrapers, the real terror begins, as the entire exterior frame aggressively rotates 90 degrees sideways, turning the side doors into a massive, highly efficient biplane wing. Inside the rotating chassis, the central passenger sphere relies on a complex, heavily reinforced mechanical gimbal system to remain perfectly upright, preventing the occupants from being violently thrown against the glass during the terrifying mid-air transition. Flying sideways allows the machine to dramatically reduce aerodynamic drag, maximizing battery efficiency to achieve over 100 miles of range through the open sky before needing to land vertically back into a standard parking space. Federal aviation authorities have already granted this bizarre machine legal certification, sparking a massive influx of thousands of pre-orders from wealthy tech executives desperate to escape the roads. Yet the most terrifying evolution of modern transit removes the human element entirely from the sprawling urban grid.
Ripping the steering wheel, accelerator pedals, and entire driver's seat out of a vehicle chassis marks the absolute death of human control over the daily urban commute. The Zoox autonomous pod is a heavy, symmetrical machine, resembling a futuristic toaster, operating with a completely bi-directional drivetrain that eliminates the need to ever perform a dangerous reverse maneuver in tight, congested alleyways. 4 passengers sit facing each other in a sterile, lounge-like internal carriage, completely surrendering their physical safety to a dense array of heavily armed exterior sensor pods that violently process millions of data points every single second. Backed by a massive billion-dollar technology conglomerate, these silent electric ghosts are currently prowling the dark streets of major metropolitan centers, using advanced predictive machine learning algorithms to map erratic pedestrian movements far faster than the human optical nerve. This relentless push towards total automation aims to violently disrupt the century-old model of private car ownership, replacing it with massive, perpetually moving fleets of sterile transport pods that never sleep, never drink, and never lose focus. Trusting an invisible network of artificial intelligence to navigate the deadly chaos of human traffic represents the ultimate terrifying gamble of the modern technological age.
If you thought this was terrifying, you are not ready for what they found in the video on your screen. Click it right now. The truth is worse than you think.